Okay, next up is something called empirical and molecular formulas. Okay, and this is a point where it's actually a little enlightening in this case because we really get to see where formulas actually come from. And I know we joked in class a little bit about, how do we know that water is H2O? How do we know glucose is C6H12O6? So when we think about formulas themselves very early on in the course, and we see formulas all the time written, we see, well, okay, we know water is H2O. We know C6H12O6 is glucose. But how do we know these numbers? Where do these numbers come from? Do we just make them up? We can't make them up, right? We need proof. So how do you get a compound's formula? Where does this really information come from? Well, in fact, it really comes from the percent composition, right? So really, the part over a whole, the percent composition idea that we did before, okay, is really done by experiment, right? We can take a compound like water or glucose into the lab, and we can separate that into separate components, right? We can break it down experimentally into the elements, right? And we can calculate the percent composition from a given sample of that particular substance. So if I gave you some glucose to bring into a lab and you broke it up into a certain mass of carbon, a certain mass of hydrogen, a certain mass of this, and you got the percent compositions, we then can use the percent composition to calculate something called an empirical formula, okay? So that's what we could do, all right? So really, empirical formula and percent composition are really the reverse of each other, because if I know the formula, if I know the empirical formula, I could find the percent composition. If I know the percent composition, I could find the empirical formula, okay? So really important. A compound's formula is found by experimentally determining the compound's percent composition, okay? And then what an empirical formula is really the lowest whole number ratio, okay, of elements in a formula, okay? And a molecular formula is really a multiple of the empirical formula, okay? So when we experimentally determine the percent composition of, by experimentally, this formula we get from the percent composition is really called something that's empirical. It's the lowest whole number ratio. Okay, so some good examples of this would be water. Water would be empirical formula because it's got a 2-to-1 ratio that can't be reduced. Okay, good empirical formula, CH, would be a 1-to-1 ratio that can't be reduced. However, a molecular formula for peroxide in this case would be a 2-to-2 ratio that could be reduced to HO, right, which would be a 1-to-1. This would be empirical. And again, a 6-to-6 ratio for molecular could be reduced to CH. Okay, so you can get the idea of how this can work. So these are called molecular because they're multiples of some lowest terms. All right, so basically how we can actually do this, and this is really the plan on how you would calculate this, is let's just say we took a CHO compound, we took that into a lab, and we found this various information. We took a certain amount of this, the whole, and we got 40% part of a whole. We got hydrogen and oxygen in these varying percentages. Well, what we could do then is take this information, okay, using the GFM. Again, what's the point of this? We're using the mole. Okay, so we're going to use the mole in this case, all right, to find some empirical formula, okay, and that empirical formula can be used with a factor to find a molecular formula if we need to. Okay, so that's easy enough to do. So again, this would be the multiple of this. So using this factor, and again, if you don't really know what's going on right now with this step, we're going to do one to practice. Okay, again, if you look at a formula up here, water and glucose, these are the numbers of atoms. Again, numbers of atoms implies that we're going to have to use the mole somehow. All right, so a good example of this is, let's just say we got these percent compositions, okay, and I used the GFM to find the empirical formula CH2O. Okay, so that would be, again, a lowest terms formula. I would then use times 6, my factor, and I would end up getting glucose. Its molecular formula, again, its molecular formula has a GFM of 180. Now check out the fact that the GFM of the empirical is actually 30 grams per mole. So it is actually 6 times glucose is 6 times greater, and that's where we get this from. So again, if you're looking at this, you're not sure what we're dealing with here and how we're doing this, that's okay. We're going to do an example, but I just want to show you that this can be done using the percent composition and using the mole. So how do we actually do this? Let's calculate one and see how we do this. All right, so very simple. Okay, and these are the steps that you're going to follow to find an empirical formula from percent composition data. All right, so to find this empirical, we're going to be given the percent composition. We're going to take those percents and we're going to change them right to grams. We're going to pretend that they're grams, because what we're going to do is we're going to have a little bit of assumption here. We're going to keep it simple by assuming that we have 100 grams of the compound. Now, it really doesn't matter how much compound you have, right? Because the percent composition is always the same. So whether you have a truckload of this substance or a little bit of it doesn't matter, but it's easy to do the calculation when you assume 100 grams. Okay, we're then going to convert those grams of each element to moles. Okay, and then we would divide by the smaller mole to change those subscripts and make them into whole numbers, and that's what we really want to do. So it's really simple little steps here. All right, so for example, how are we actually going to do this? Well, let's just say we want to find the empirical formula. Okay, so the lowest whole number ratio, okay, of a compound that is 25.9% nitrogen and 74% oxygen. So what are we trying to do here? Basically, and let's just say we were in a lab and we have this mystery compound. So this mystery compound has an N in it, and it's got an O in it from experiment, and we don't know how much N, and we don't know how much oxygen. So we're trying to find these numbers. Okay, so what I'm going to do is I'm going to set it up with N. I'm going to set up a little line with O. Okay, and I'm going to use this as my calculation line here. Okay, so first step, I'm going to take my percentages. So I have 25.9% nitrogen. Okay. In fact, what I'm going to do here is do this again. I'm going to make it a little bit different here. Okay, so again, I'm looking for N and I'm looking for O, these variables. Okay, so I'm going to take my N and I'm going to say, I'm going to change my percentages right to grams. So I'm going to take 25.9% and I'm going to get 25.9 grams. And my oxygen, I'm going to take 74.1% oxygen. I'm going to make it in grams. So this is grams of nitrogen. This is grams of oxygen. Okay. Now, what I'm going to do here is go to step 2. I'm going to change directly to moles. So how am I going to do that? Is I'm going to grab my calculator. I'm going to divide by the GFM of nitrogen and divide by the GFM of oxygen, which is 16. Okay. And I'm going to get a mole amount. And this is where the magic begins. So I'm going to say 25.9, divide that by 14, and I'm going to get 1.85. Okay, and if I do that for the oxygen, I'm going to get 74.1 divided by my 16, and I'm going to get 4.63. And I suggest taking this out to 2 decimal places is probably the best thing. Now, again, these are moles, right? Because we divided by GFM, got into moles, and guess what I did? I actually made my first subscripts. Now, of course, these are really ugly looking. Okay, and again, we would never have subscripts that are fractional like this. So we got to find a way to get those into whole numbers. So I'm going to go to step 3, and I'm going to divide by the smaller mole. So I'm going to look at these 2 numbers, find the smaller one, that's easy, and I'm going to divide by that number. So I'll divide by that number 1.85, divide by 1.85, okay, and I'm going to get a 1 here. So I'm trying to get that ratio from 1 to something, if I can do that. All right, and I'll take 4.63, and I'll divide by 1.85, okay? And I will get 2.5. All right, so these numbers look better. So what did I do here? I really went 1.85 here, divided by 4.63, and I'm going to track this along, and I got N1 and O2.5, which still doesn't really look that good. All right, so I'm not happy with that. So I didn't include that in the list here, but sometimes when you get to this step, you may be done, and you may not be done. What you want to try to do here is then take these and try to adjust them to get them both whole numbers. And the only way you can really do this is multiply both by 2. So if you multiply both by 2, then you get yourself full whole numbers. And that's what we want to do. So we're going to get 2 here, and we're going to get 5. And now I am done. And now I'm going to have N2O5. You found your subscript. You know that's cool. You know that's awesome. And you did this by experiment. Okay, so again, you would get this in the lab. You would get the 25% and that from actually analyzing the elements that are in the formula by decomposing them. All right, so that would be the empirical formula. Okay, and again, this calculation will always give you the empirical formula because now you have a 2 to 5 ratio, which is in lowest terms. Okay, so that's a good way to do it. All right. All right, so if we want to try one more, I'll do one more here with you. If we go backwards one more, we can try one more here real quick. Okay. And again, I'll let you do them. I'll let you do the next two on your own. Okay. Let's just say I have 79.8% and 20.2% hydrogen. I get my line going for both. I suggest you do it this way. So we'll take 79.8 grams of carbon divided by 12. We'll take 20.2 grams of hydrogen divided by 1. Remember, okay, we're not doing it by 2. This is not diatomic. We're talking about hydrogen itself. Okay, this one's easy. We get 20.2 moles. Okay, because that, and then we're going to get 79.8 divided by 12 carbon is 6.65 here. Okay, now of course the smallest mole is the 6.65. We'll get 6.65. We'll do 6.65 in this case, okay? And then we'll get 1 is here, okay? And we'll get 20.2 divided by 6.65 here, and we'll get a 3.03. Now, since this is close enough here, we're just going to say that's approximately equal to 3. Again, these are experiments. They're going to have some error to them, so we're going to have to be close enough. So if I put this together, we will have CH3 as my empirical formula. Okay, so I'm going to let you do this on your own, okay, and you can figure out what you're going to do here, okay, and you can end up, all right, and again, you can check this. We can do this in class, and you can check your answers at that point. All right, so next part is something called the molecular formula. Now, a molecular formula is after you get the empirical. Okay, a molecular formula is simply a multiple of the empirical after you get it. So let's just say we have the empirical formula is CH, okay? And you want to find the molecular formula. And there could be many molecular formulas. You could see that you have these factors where the molecular formula is a multiple of that. We can have a multiple of 2, and we can even have a multiple of 6. Okay, to get this molecular formula. But notice also that the empirical formula in this case is 13. If you multiply it by 2, not only do the subscripts multiply by 2, but the GFM also does as well. Okay, so that's important to know that the GFM is also a multiple of the empirical's GFM, and that's where you get the factor from. So if you don't know what the factor is, it's very easy. So let's just say if, for example, we knew the empirical formula of CH is CH, so that would be a GFM of 13. Well, what if I didn't know? What if I was trying to find the empirical formula? I'm sorry, the molecular formula, the multiple, and I knew that this was 78, right? Well, then I can take 78, I can divide that by 13, like you see here in the example, and when I do that, I get 6. And that's how I know to multiply this by 6 and to get C6H6. Okay? So we're going to use the GFM of the empirical and the GFM of the molecular to find that multiplication factor. Okay, so you can see why, whether it's 26 or 78. So we can see how this works here. It says, all right, so it says, what is the molecular formula of a compound? So you're trying to find the multiple with an empirical formula of NO2. So we know NO2 is the empirical formula. All right. So what we're trying to do is we're trying to find the molecular formula of some other compound. So we really don't know what this is, right? So if we do a little different, so we don't know what this compound is. We don't know what the multiple is. But we do know that the multiple's GFM is 92 grams per mole. So what I can do is find the empirical's GFM. This is the empirical. We can find the empirical's GFM compared to the multiples or the molecular GFM, and then find the factor. So I'm going to find the GFM of my empirical. So I'm going to say this. Nitrogen is 14 times 1. Whoops, times 1. Oxygen is going to be 16 times 2. Okay, so this is going to be 14. This is going to be 32. This is going to be 46. Okay? All right. So now what I'm going to do is you can see that if you compare the empirical one to the molecular one, you'll see it's a multiple of it by exactly 2. Sometimes this is easy to see, sometimes it's not, but we can follow the little formula. We can say the empirical over the molecular. Okay? So we could take 92 grams per mole over 46 grams per mole is equal to 2, and that becomes my factor. So now I can take NO2, I can times it by, I can multiply by 2 here, and now I can get N2O4, and that is my molecular formula. Molecular formula. Okay? And that's the way we can do this. All right, so that's the thing you want to be able to do here in this case. Okay, that would be the best way to do it. All right, and then what I'm going to do is then is if we can go to the next page. Okay, again, these pages, this is going to be a way you could do this. All right, same way you do it in example 3 here, 2, and the same way you do it in example 3 here. Okay, same idea. Okay, and then if you want to put it all together, what you would find, okay, is putting all together is now taking the empirical one that we did in the previous examples and also finding the molecular one if we combine the both ideas of empirical formula. So I'm going to let you handle these on your own and fight through them, and we'll get the answers up a little later on. Okay? And that's the case there. Have a great day.